Thank you, Ines. So that's it. Ines asked me, and I was like, I don't remember Nicolas Cage movies in English, because I have never watched it in English before. So that's it. Hello, everyone. I'm very glad to be here. My name is Carla. Today, I'm going to talk with you about artificial intelligence ethics and bias. That's my research topic. So first, let me introduce myself. I'm a data engineer and Google developer expert in machine learning. I'm doing my master's research about AI interpretability and ethics. And some fun facts. It's my first time in the US. It's my first time speaking in an international conference in English. And yay. And it's my first lead dev event, so please be nice. Speaking a second language is really hard, so I hope you like the talk. I'm from Brazil, as I mentioned before, and these are my social media, but I will share with you later. So, first, I'm a developer for a living, so every time some breaking news about robots taking over the world and stealing our jobs, that's me. My friends and family message freaking out about how, are we gonna die? And I'm like, no, you're not going to die. And we see this everywhere, this media panic about robots taking over the world. We could blame Hollywood for that. But in reality, that's not the problem we should be focused on, in my opinion. There is a more pressing danger, a bigger risk with AI that we need to fix first. So we can see that complex social and political challenges are being automated as machine learning models, and that can be really dangerous. AI is being used to decide how much you pay for your car insurance, how good your credit score is, and if you are a potential suspect. So one of the promises of AI is to help you reduce the unconscious bias of human decisions, and that's really cool. But in reality, bias is like a virus that travels and is replicated by machine learning models. So, in this slide, you have 5 potential harms caused by AI systems. These harms were listed by the Understanding Artificial Intelligence Ethics and Safety Guide. It's a really cool guide if you want to learn more about this topic. It was built up from Alan Turing Institute. So the first one is bias and discrimination. The second one, denial of individual autonomy and rights. The third one, non-transparent, unexplainable, or unjustifiable outcomes, invasions of privacy, unreliable, unsafe, or poor quality outcomes. So I'm going to focus today on the first and the third ones to discuss with you about that. So, what is bias in machine learning and artificial intelligence? So bias can have different meanings in different areas of study. For machine learning, think about algorithmic bias is when a computer system reflects the implicit values of the humans who created it. We can think, remember that bias is a human characteristic. We all have our own biases, and that's totally fine, as long as we recognize it and take responsibility for it. So every day we make countless decisions based on our gut feelings, but you have to be aware of that. So I don't like saying that bias is unconscious, because we have been talking so much about that, that at this point we are all here aware that we have bias, so it's not unconscious anymore. I like this quote from Joy because it summarizes what I just said. Despite our aspirations for tech to be better than us, to be more objective than we are, the machines we create are a reflection of both our aspirations and our limitations. So we have to have that in mind when you are developing artificial intelligence, when you are creating a product that is based with artificial intelligence. So, we know bias comes from humans, but how they become part of the machine learning and AI systems. So to understand that better, I believe it's worth to explore the machine learning life cycle. So in this image, you have the machine learning pipeline, summarized, of course. So we have different steps where you can have human bias, since data collection, data labeling, training, stage, deployment to production, users, because machine learning can create feedback loops. So if you have a social media, your algorithm is impacted by the users, and if the users have some kind of prejudice, this is going to affect the algorithm itself. So you can create feedback loops. So the user behaviors impacts the machine learning model, and you have to be aware of that. So your product is inclusive to all types and different users. In this image is a more detailed view of the machine learning life cycle. This is from an article named A Framework for Understanding Sources of Harm Throughout the Machine Learning Life Cycle. In this paper, the authors provide 7 sources of bias in the machine learning life cycle. So you can have historical bias, representation bias, measurement bias, learning bias, aggregation bias, evaluation bias, and deployment bias. I don't have time to dive deep on this, but I highly recommend you reading it to understand better how which one of these bias can happen in the life cycle. So, to understand bias better, I like this analogy from my friend Cassie Kozikov. Data sets are like textbooks. So we are talking about a machine learning. You can have students learning from textbooks, and the machine learns from data sets. And textbooks have human authors, and so data sets. Sometimes we forget that, but someone is going to collect data, someone is going to label that data. So someone is deciding which variables are going to be used by the model to make decisions. In all these points, you can have human bias. So think of the machine learning as the student, and you are the professor. And as the teacher and professor, you have to choose examples, and I hope you choose good examples to teach the machine. Because the whole point of AI is explaining your issues to a computer using examples, data, instead of giving direct instructions. So which examples? As I said, it's your choice as the teacher. So if you give crap data to the machine learning model, I try to represent with this emoji, you're going to have crappy results. So AI learns from whatever we give it. If you give crappy data, you're going to have crap outputs. So we have to be very careful with what we teach machines, what data we give them, so they just don't repeat our own past mistakes. So I'm going to dive deep more on the different types of bias. So the historical bias is, it arises even if the data is perfectly measured and sampled. Sometimes you can have data that is really and highly representative of the population you are trying to solve the problem, but sometimes you can have bias in there, even you couldn't know before. So this can happen. This happens a lot in some cases when we speak about racial bias, because sometimes the name of the person or where the person lives has a right correlation with its race. So even though race is not a variable in the data set, other variables can reveal a person's sensitive attribute. So you have to be careful with that as well. Representation bias occurs when the development sample underrepresents some part of the population. As an example, I have here ImageNet and OpenImage. So ImageNet is widely used by the computer vision community, and unfortunately, 45% of the images in ImageNet were taken in the United States. So it's not represented for people like me that comes from South America. So using this data set to solve Brazilian problems is not going to work, because we don't have data from Brazilian people in reality. So many data sets have this problem. They come from the North America or Western Europe, and they're not represented to the global South. Evaluation bias. This bias comes from data scientists mainly, When we are evaluating a machine learning model, usually we consider efficiency, accuracy, and this type of metrics, but they can hide underperformance between some subgroups of the data. So even though you have a good metric for, in general, from average, you can have different accuracy metrics for different groups. Like in facial recognition, you can have 80% of accuracy for, in general, but when you look closer, you're going to see that you have like 6% of accuracy for a white man, and you have like 20% of accuracy for black women. And that's not cool. So you have to be really careful with that, because average can hide bias. So we need to change how we evaluate these machine learning models as well. Recent research has proposed new metrics to evaluate the performance of machine learning models. So to consider bias, fairness, discrimination, one example, as I mentioned, is comparing accuracy between different groups. So you can understand better how your model is behaving between these different groups, and if it's being fair. I know that fairness is difficult because it can have different meanings. Each one of us have a different meaning of what is being fair. I know that. But we've been trying in research to define some common metrics to have some kind of agreement what is a machine learning model to be fair. And we have deployment bias. The deployment bias comes mainly from the humans that are going to use the machine learning model as a support for a decision. For example, it depends from how the humans are going to interpret the decision makers made by the machine learning model. So the people who are using this machine learning model to support their decisions, do they know how a machine learning model works? Do they know when they have to contest the machine learning decisions? So deployment bias arises when there is a mismatch between the problem a model is intended to solve and the way in which it is actually used. One important thing is also that algorithms sometimes cause this illusion of neutrality. So some people may think that using a machine learning model is better than having humans taking decisions because humans have bias. But as I mentioned and showed you, bias is a virus. So machine learning models also have human bias. There is a term for that. There is math washing. This was coined by Freddie Benenson. It means, and it happens, when power and bias hide behind the facade of neutral math. So you have to be aware that math is not neutral, AI is not neutral, and humans are not neutral. And also, I want to emphasize that bias doesn't come from AI, it comes from people. If we keep saying that AI is biased, we are like outsourcing our responsibility. Along with that, we have another problem besides bias. We have the black box problem. So the current generation of AI systems are what we call black boxes. So even when inputs and outputs are known, these systems can suggest answers, but not say the why behind their decisions. This makes it, sorry, my throat. Brazil is really hot during this time of the year. It's like, I don't know how to say this in Fahrenheit, so I'm not going to say it, because you're not going to get it. Just a moment for me to have water. So black boxes make it difficult for a user to trust the machine, and also it makes more difficult for data scientists to detect potential biases and mitigate them. So sometimes the user may be wondering, what is driving the model decisions? Can I trust this model? When I know the model is failing, when I know the model is working as expected, how the model works. So we developed complex models for complex problems. We didn't have deep learning when AI was invented. So now we have deep learning and complex machine learning models, but along with the complexity, it became more difficult for humans to understand how they work. But what can we do to solve this? What is our role on this? So I like this TED from Zainab Tufek that she says that machine intelligence makes human morals more important. So we cannot outsource our responsibilities to machines. We cannot expect machine learning to solve bias by its own. So I highly believe, that public sector organizations can anticipate and prevent these potential harms by creating a culture of responsible innovation and by putting in place governance processes that support the design and implementation of ethical, fair, and safe AI systems. So we have fairness as a potential solution to help us. We can consider an algorithm to be fair if it makes predictions that do not favor or discriminate against certain individuals or groups based on what we call protected or sensitive characteristics. So fairness, in summary, means a statistical analysis to understand how the model behaves across different groups. In the image, you have two scenarios. So there is a scenario that is unfair, and there is a fair scenario. In the unfair scenario, you have positive and negative predictions, and they are in different proportions for group A and group B. In the first scenario, you have the same proportion of positive and negative outputs for the both groups. That's the kind of scenario we expect with fairness. Also, we have explainable and interpretable AI. That's my research focus on. So explainability is not a new issue for AI system, but it has grown along with the success and adoption of deep learning. Now, as I mentioned, the current generation of AI systems offer tremendous benefits, but their effectiveness will be limited by the machine's inability to explain its decisions and actions for users. So we have to understand better what is an explanation. That's difficult to answer, because explanations are different depending on the stakeholder. So the explanation you are going to provide a data scientist is totally different of the explanation you are going to provide your user or consumer. Because an explanation provided to the data science is going to be a metric, it's going to be a graph, something more technical. And for the user, you just want to explain how your product works. If you work with a credit score, you want the user to know what is impacting their score to positive or to more negative scores, for example. So this image is from an article, and it's really cute. I think it gives the message really clearly. So it shows different stakeholders: data science, business owner, model risk, regulator, and consumer, and what they want to know from the model. So a data scientist wants to understand the model, debug, improve its performance. A business owner likes to understand the model, evaluate fit for purpose, agree to use. So you have the model risk part, trying to challenge the model, ensure robustness, and approve it. And also you can have regulators that need to know how the model works, and you have to do it in a safe way. You cannot give the code. You have to think about how explaining the model without violating privacy of your users. And the consumer that wants to know the impact on their lives. This graph shows the boom of XAI during 2019. So there were a lot of articles discussing XAI, interpretability, explainability, but at some point, the community discovered that creating explainable AI is not easy as expected, as is related in Medium articles. That is harder than that, because it depends on a lot of different aspects. It depends on the problem you're solving, on the company policies. It depends on the users, on the data you're collecting, and what the company is intending to explain. So that's actually really hard. I don't have the answer here, sorry. Nobody has, everybody's working and researching to have more people discussing that and creating better solutions. Some of the challenges I've discovered during my master's. So we have a lack of global explainability methods. We are trying to think how to avoid ground truth and justification, how we can better evaluate explanations. For example, I have a method that's going to generate explanations for a machine learning model. I'm going to have to evaluate that method as well to see if it's generating explanations that are making sense. How we can do better explanations for non-expert users. So we need design, UX people working together for that. How does fairness interact with interpretability? And how can we build more robust interpretability methods? And also, how to combine and deploy interpretable machine learning models. I'm a data engineer, so I'm always asking myself and studying on how can we, on the machine learn, ML ops flow, how can we insert fairness and interpretability steps automatically so we can have these metrics. And also, I think it's important to think of AI as a product, because it's going to be a product at some point. It's part of something bigger inside each company. So we have to think, who is your invention for? Who benefits from it? If you are thinking about using AI to solve any problem, you have to think about that. And I think UX people can help with that, because it can map your application's users. Also, is it ethical to proceed? What if your idea isn't uniformly beneficial to everyone? While mapping out your ideal use case, consider those who might get harmed by the existence of your system. Also, can any humans be harmed by your application? This is especially important if your technology scales to millions and billions of people. And remember, just because you can do something doesn't mean you should. Okay? Remember that. Also, think about the humans your creation impacts, who benefits and who might be harmed. If you care about developing technology in an ethical and responsible manner, it is your duty to think about all people your creation could affect. Thinking about them after you've built it is irresponsible. The time for doing it is before, during the development. So an AI ethicist can help you with that. Their participation in the project is highly important, as they can help you ensure that groups affected by your creation are given a voice. For example, you should expect better performance on examples that are similar to what your system learned from. So a model that identifies swamps is likely to fail when presented to an image of a black swan, as they are not very common. That doesn't mean you shouldn't develop your model or train your model to understand what is a black swan. So many data sets are not representative, and this also happens with facial recognition models. So it's your duty to think about the pain you could cause to people when your model fails. And yes, it takes a lot of effort and imagination. You have to think about really different scenarios, futuristic scenarios for that. And one last thing that's really important, diversity of perspective matters a lot. When you think of the perfect data science team, are you imagining 10 copies of the same professor of computer science and statistics? I hope not. Applied data science is a team sport that's highly interdisciplinary. So if you want to do it in the right way, you need people from different backgrounds, they have different experience. So this matters as much as education and experience. For summary, remember, technology is not free of humans. Math can obscure the human element and give an illusion of neutrality and objectivity, and every single human is biased. I've said a lot here when I could just told you that most of the research on this topic It's about making sure that your system doesn't have a disproportionate effect on some group of users relative to others. The reason I spend so much time on this topic is that I want you to do even better, because simply creating a fairness metric may not be enough. No one knows a system better than its creators, so if you are building one, take the time to think, critically think. Think about how your actions will affect people, and do your best to give those you affect a voice to guide you through your blind spots. Remember, there is always a human behind the machine. The trouble begins when you forget that. Thank you.